Hello, I'm going to do a help video for example problem 3, and a heads up, this matches the same setup as one of your questions on, I think it's the quick check for this lesson too. So if you can understand this problem, then you should be able to understand that one as well. So for problem 3, we're going to be using a graph to understand the pattern here. So it says that you want to set up an aquarium and need to determine what size tank to buy. The graph shows tank sizes using a rule that relates the capacity of the tank to the combined length of the fish. So there is a rule or pattern, okay, that relates, that's going to connect two things. So the capacity of the tank, it's a fancy way of saying the size of the tank, how much it can hold, is connected to the combined length of the fish. And that should make sense. The more fish I have in there, the bigger a tank I need. And there's a direct relationship with that. So the question says you want 5 2-inch fish, 4 1-inch of the guppies, and a 3-inch float. And what is the smallest capacity tank you can buy? So do you want the 15-gallon, the 20-gallon, or the 25? And use a table. So in order to use a table to figure out what is this relation, what is that pattern, first they wanted you to choose some points on the graph. So they've picked this point, this one, and this one. And when you're working on the quick check problem or doing this, you could pick any point you want. Notice it's a straight line. That means it has the slope is staying the same. So you can solve the question no matter which points you choose. And when you're picking your points, take a second to understand what they mean as well. So they're saying if you have 0 inches, combined inches of fish, you need at least 2 gallons. That's our starting point. Okay, and then if we have 2 inches, combined length of fish, you would need 4 gallons. If you wanted 3 inches, it's 5 gallons. Okay, if I have 5 inches, you need at least 7 gallons. Okay, so our x component, our x coordinate is the length. So 0, 5, 10 in the examples we picked, that's our length. And our y coordinate is going to be the capacity. That's 2, 7, and 12. That's the gallons you need. Okay, so all they've done is set that up into a table. Your input is your x coordinate, your independent variable, and your output is your y coordinate, okay, your dependent variable. How many gallons you need depends on how many fish you're putting in there, that length. So the process column, that's where they've figured out the pattern. So they've kind of worked backwards here and said, okay, well, if we had, no fish, I had an output of 2. So they're filling in 0 and 2. Well, what do I have to do to 0 to get 2? I added 2. When I had 5 inches combined length of fish, I needed 7 gallons. So what is that process? How do I get from here to here? Again, they added 2. Same here, if I have 10 inches of fish, our output is 12. Okay, that's coming from the graph. 10, 11, 12 gallons. How do I get from 10 to 12? Well, I added 2. Okay, and you're adding 2, so the overall rule or the pattern here okay, you take your input, how many inches of fish you had, and you add 2. So if you want 5 of this type, 4 of this type, and 1 of this type, that gives you a total of 17 inches. If I follow the rule, 17, That's my input, plus 2. I need a 19-gallon tank minimum. And then the question told me, well, they only sell them in 15, 20, or 25 gallons. So 15 is going to be too small. I need 19 gallons. 25 is going to be bigger than you need. So I need to buy a 20-gallon tank. Okay, let's do one more example. The graph at the right shows the total cost of this particular type of fish at the shop. So this is the number of that type of fish here. This is our input. It's our X variable. This is the independent variable. Okay, and you'll learn that vocabulary as you continue in the class. And then along the y-axis, this is our output, our dependent variable. Okay, the cost depends on the number of fish you buy. Okay, so let's look at the pattern. Same steps as before. Let's pick a couple points. So we have 0, 0. We have 1, 2. We have 2, 4. And 3, 6. Okay, so we're going to make a table just like the last question. You have your input, what the rule or process is, what's happening to it, and then our output. Okay, so our input, if I have no fish, costs me nothing. If I have 1 fish, costs me $2. 2 fish cost $4. And 3 fish is going to cost you $6. So what's the process? How are we getting from here to here, here to here, here to here? And just like earlier, it needs to stay the same. Okay, pattern has to stay the same each time. So you might notice, and if you're like, oh, okay, how do I get from 0 to 0? I don't do anything. You can use any of these points. So let's look at maybe instead 3 to 6. How do I get from 3 to 6? Well, you could do plus 3. Right? 3 plus 3 is 6. And let's see if that pattern works for the other questions. So is 2 plus 3 4? No. Is 1 plus 3 2? No. So that pattern doesn't work, which is no big deal. Try another one. So what's another way to get from 3 to 6? Well, you could multiply by 2. Three times 2 gives me 6. Let's see if it works. 2 times 2, that gives me 4. 1 times 2, that gives me 2. And 0 times 2 gives me 0. So now I have my rule. I take my input and I multiply by 2. So how much is 6 of this type of fish going to cost? Well, that's my input is 6 times 2. It's going to be 12. It'll cost you $12. How many do 10 cost? Well, that's your new input, 10 times 2. That's going to cost you $20. Okay, so choose a couple points on the graph. What's your input? What's your output? And then once you find that pattern, you can apply that to your other questions. All right, and here's a question, another one to think about. Why is the graph in problem 3 a line while the graph at the right is a set of points? All right, so for this one, they didn't just have the points. There's a line that connects them, okay? Which means that any point on this line is correct. It is part of your pattern. So, for example, this is the tank size and how many gallons you have filling it up, right? So if I have a gallon tank and I pour in 1 gallon, right? And you want to keep filling that. As you're filling it with water, you also have all of the sizes in between. So that tank, it's not some kind of magic tank where as you're pouring the water in, it jumps from 1 gallon to 2 gallons to 3 gallons to 4 gallons. It has all of the volumes in between as well. So there's 1 gallon, and then 1.1, then 1.2, 1.3, 1.4, 1.5, 1.6, all the way up to 2. Okay, so they show these lines to include that you can use any of those points. So for example, I could take this point right here and say, oh, that's 8.2 gallons. Here we're talking about number of fish. So those obviously have to be whole numbers if you want the fish alive anyway. So I can put in no fish, I can put in 1 fish, I can put in 2, 3, 4, 5, 6, 7, and keep going. But I can't put in half of a fish or 2.5 fish. So these spaces here are not included. That's why there's not a line connecting them. If I put a line connecting these, then I would be saying that I could put in 1.2 fish, 2.3 fish, and that doesn't make sense for this situation here. Okay, so just if you're plotting something on a graph, don't automatically connect them if it's something like the volume and it's continuous. Okay, so this one is continuous. You can take any point here, whether it's a whole number or something in between, put it in the equation, it still makes sense. But this graph here is discontinuous. Okay, it jumps from each whole number. Okay, because in this story problem, it doesn't make sense to have half of a fish. Okay, so if you have any other questions, reach out to us, and hopefully this was helpful.